Hello, and welcome to this fourth lecture of parts identification and process design in this course on developing winning prototypes. I'm Arun Singhal, your management coach and mentor with 40 years of experience in people development. So, in this section, we've been working on giving you a good understanding of how to identify the parts and then design the process to develop a prototype that can help you build a business. And what we're going to do in this lecture is to see how can we evaluate the product designs that we would have made so far. So how do we evaluate product design? Any thoughts? And in this, you see on your screen an overall process of this evaluating the product design, and it starts with evaluating product design, then finalizing specs, developing correlation between product process requirements and developing process requirements, right? So how do you think you can evaluate product designs? What we use is a technique called design of experiments in this step, and we start with developing a detailed product design using design of experiments. So for example, if there are three possibilities of three particular parameters that we need to choose from, and we could set up the values at 1 or 2, we could possibly think of setting up 8 experiments with various combinations of 1 and 2 for A, B, and C. And so we have 8 experiments there. And these A, B, C are actually the amplitude, slurry concentration, and slurry type. Right, and then what we do is we determine the actual values as you see on the right hand side, and that tells us which of these 8 combinations is the most optimal combination for us to pursue, and that starts determining our combination of inputs and process to determine a most optimal design. So how do we do this? How does this DOE look in our water purifier example? So if we go back to our parts requirements here, there are 3 critical parts, and the most important aspect of the water purifier is the ability to bond the fine size silver nanoparticles uniformly and firmly on the rice husk ash. And the second requirement is that once bonded, the release of silver particles from the incoming water should be very minimal, if not completely curtailed. So how can we achieve that? Let's look at that in this design of experiments. So what the scientists or the engineers that were working on this project found that there were 3 parameters, 3 things, 3 factors that determine the process of bonding silver into the rice husk and releasing the particles into the incoming water. So one was the reducing agent that we use in the process, second was a stabilizing agent, and third was the coating sequence. And there were 2 alternatives for each of these. For the reducing agent, you could use trisodium citrate or sodium borohydride. For the stabilizing agent, you could use ethyl hexyl palmitate or polysaccharide. And the coating sequence was that we could do the coating pre-binding or post-binding. And as a result of that, we could generate, as we would have expected, 8 experiments possibly. And you can see the experiments on the right hand side. We have different combination of the reducing agent between TSC, SBH, and ethyl hexyls and polysaccharide, and the coating sequence of being pre-binding and post-binding. So we have 8 experiments. So they set up these 8 experiments. And they ran the experiments to see, they did the coating, they ran the water flow, and they found what is the loss of silver ions to the water. And from this, they could find the best designs. And the release was minimal in case of using TSC and polysaccharide in pre-binding stage, and even with SBH and polysaccharide combination in pre-binding. So that's how they determine the most optimal design in terms of the reducing agent, stabilizing agent, and the coating sequence. So what they found is to minimize the silver release, we could go with the following options. Coating sequence, pre-binding is better because, as you can see, all across the pre-binding results of release of silver is lower than post-binding results. And the stabilizing agent, also the polysaccharide results are far lower comparatively to the other option that we have. The reducing agent did not much have impact on the silver release. So like this, you determine using the design of experiments, what is the best. You evaluate the various design possibilities that you have in terms of the various parts, components, as well as in the process. So having done that, what do we do next? In the next, we will look at how this evaluation of DOE can help in finalize the specifications, and we will take a look at in the next lecture, right? So thank you so much for watching this fourth lecture of parts identification and process design in this course on developing winning prototype. I hope you continue to learn something new, continue to enjoy, and I look forward to see you again in the next lecture.